Hello students, welcome back to part 4. Here we are trying to solve previous year JEE questions on quadratic equations. If you have not gone through first parts, you can refer the corresponding links in the description. Let's go. Question number 17 says if roots of the equation x square minus bx plus c equal to 0 be two consecutive integers, then b square minus 4c equals. So roots are two consecutive integers. This is the key statement. So for this x square minus bx plus c equal to 0, we can assume roots as alpha and beta, where beta can be next root, that is consecutive integer, that is alpha plus 1. Okay, so beta is equal to alpha plus 1. We can say alpha minus beta equal to minus 1. Right, students? So alpha minus beta the whole square would be 1. Alpha minus beta whole square can be written as alpha plus beta whole square minus 4 alpha beta. Right, alpha plus beta is sum of roots, which is just b by a minus of b by a, that is b square minus 4c is equal to 1. So the answer is D. Okay, question 18 says the equation e raised to sin x minus e raised to minus sin x minus 4 equal to 0 for real For real x has infinite number of solutions, infinite number of roots, no roots, exactly one root, exactly four roots. Okay, let's start. Now, e raised to sin x minus e raised to minus sin x minus 4 equal to 0. Let's assume e raised to sin x as y. So we have y minus y raised to minus 1 minus 4 equal to 0. This becomes y minus 1 upon y minus 4 equal to 0. That is y square minus 4y minus 1 equals 0. So the roots are, by formula method, minus b plus minus under root b square minus 4ac upon 2a. I am directly putting values, which is 4 plus minus root 20 is 2 root 5 on 2. So 2 plus minus root 5. So we can say e raised to sin x is 2 plus root 5, or e raised to sin x is 2 minus root 5. Now there is an important point to note, students, that sin x always varies between minus 1 and 1. We know this fact, right? So if we take e raised to sin x, it will vary between e raised to 1 and e raised to minus 1. Correct? That is 1 upon e and e. Now if you know, value of E is 2.7 approximately. So 1 upon E would be approximately 0.3. So this value e raised to sin x lies between 0.3 to 2.7, whereas these values root 5 is 2 point something, so this is 4 point something, right? And this is negative value because root 5 is greater than 2. So e raised to sin x cannot have negative value, e raised to sin x cannot have value 4 point something. So as per the obtained equations, this equation has no roots. Okay, no value of x can satisfy these conditions. So answer is B. Okay students, question 19 says if the equations x square plus 2x plus 30 and ax square plus bx plus c0, where a, b, c are real numbers, have a common root, then a is to b is to c is how much? Let's start solving. There are two equations having a common root. Let's have this equation first because it is completely known. For this equation, discriminant delta is b square minus 4ac, that is 12. Oh, it is negative. Delta is negative means roots are imaginary. Okay, students. So first quadratic has imaginary roots, but this quadratic and the other quadratic have one common root, right? One root is common. So if this has both imaginary roots, then this equation will have one imaginary root. But we know that if roots are imaginary, they will appear in conjugate pairs always. So if this equation has one imaginary root as a plus bi, its other root has to be a minus bi. Okay, I'll repeat again, students. This and this has one common root, as the question says. But the point is, roots are imaginary, and imaginary roots always appear in conjugate pairs. That means even if they have one common root, the other must be common because it is obviously the conjugate. So the bottom line for this discussion is these two equations do not have one common root, they have both common roots. And if both roots are common, then these coefficients a, b, c must be identical, right? Or at least they should be proportional. So a by 1 should be equal to b by 2 should be c by 3. Means a is to b is to c is 1 is to 2 is to 3. Let's move on to question 20. Let alpha and beta be the roots of the equation x square minus 6x minus 2 equal to 0. If an is equal to alpha raised to n minus beta raised to n for n greater than or equal to 1, then the value of a10 minus twice a8 upon 2a9 is. Okay. So basically, alpha and beta are roots of this equation. Alright. Let's start. X square minus 6x minus 2 equal to 0. This has roots alpha and beta. If alpha and beta are the roots, we can substitute alpha beta in place of x. So alpha square minus 6 alpha minus 2 is 0 and beta square minus 6 beta minus 2 is 0. So alpha square can be written as 6 alpha plus 2. Beta square is 6 beta plus 2, right? Now, what we need, students, is a10 minus twice a8 upon twice a9. Let's see what is this. A10. A10 is alpha raised to 10 minus beta raised to 10 minus twice a8 is alpha raised to 8 minus beta raised to 8. Denominator is twice a9. a9 is alpha raised to 9 minus beta raised to 9. So basically we need to deal with power 10, 8 and 9 over alpha and beta. So what we can do is we multiply this equation, the first alpha equation, by alpha raised to 8. So when we multiply by alpha raised to 8, we get alpha raised to 10 is 6 alpha raised to 9 plus twice alpha raised to 8. Similarly, beta raised to 10 would be 6 beta raised to 9 plus twice beta raised to 8, right? Now, if you look at the required expression, slowly you will start realizing that we should subtract these two equations. So if we subtract these two, we get alpha raised to 10 minus beta raised to 10 is 6 times alpha raised to 9 minus beta raised to 9 plus 2 times alpha raised to 8 minus beta raised to 8. Let's move this term on the left hand side. So we get alpha raised to 10 minus beta raised to 10 minus twice alpha raised to 8 minus beta raised to 8. In the RHS, it is 6 alpha raised to 9 minus beta raised to 9. Alright. Now, we should divide by this bracket. Alpha raised to 10 minus beta raised to 10 minus twice alpha raised to 8 minus beta raised to 8. In the denominator, alpha raised to 9 minus beta raised to 9 is 6. So I have tried to arrange this term which is required quantity. Now just this 2 is remaining. So to introduce that 2, we divide both sides by 2, and so this 6 upon 2 is 3 is our required answer.